Hello everyone. Welcome to this lecture on interpolation. Basically, what is interpolation? Okay. This is a very important topic that you're going to study now, and this particular thing you're not only going to use in this particular course, but also in your real life. Okay. So, in which situation you're going to need interpolation? Okay. So let us say you have some scientific data and you have taken a recording. You have recorded the scientific data. So this is some function, and this is the location, and you have recorded the value of something at this location. It may be pressure or something. Okay. So this is the data. Suppose you want to find out the pressure, or let's not let's say a value of function at 40. That is in between 23 and 51. So don't you think the gap between 23 and 51 is very much? So the problem here is you cannot again record the data. Okay, but you want to find out the value of the function at 40. So what you're going to do here is you're going to use interpolation. Okay, so what you're going to do is you're going to fit the polynomial between these points. Okay, and you're going to find out the polynomial, let us say a1x, a0x, or a0 plus a1x plus a2x, and so on. So what you're going to do is you're going to fit this polynomial through this data. Okay, and you're going to find out that polynomial. Okay, and once you find out that polynomial, you're going to substitute the value of 40, and you're going to find out the value of that particular function at x is equal to 40. So I hope everybody is clear with this particular point. So this is very important thing that you need to understand. So there will be a lot of situation in your real life where you'll have a sparse data and you'll have to find out the values in between. So what you're going to do is you're going to use interpolation. Okay, so there are different types of interpolation: first order interpolation, second order interpolation. So basically when you use first order polynomial, it is first order interpolation, second order polynomial, second order interpolation, third order polynomial, and so on. Okay, higher the order, the more accurate will be your answer. If you use the fifth order polynomial to find out the value of 40, it's going to be more accurate than what you find out using a third order polynomial. Okay, so this is where your interpolation is used. So now when you talk about interpolation, there are two methods for finding out the interpolating polynomial. So the first method is Lagrange polynomial, or Lagrange interpolating polynomial, or Lagrange interpolation. And the next is Newton's divided difference method. Okay, so to find out interpolation of a given data, you have two methods. First is Lagrange interpolation, then the next is Newton's divided difference. Okay, both are very interesting method. We are going to see one by one. So Lagrange interpolation is also known as, I'm really sorry for here. Lagrange interpolating polynomial, and this is known as Newton's interpolating polynomial. So now let us talk about the first, that is Lagrange interpolation. Okay. So the formula for calculating Lagrange interpolation is very simple. So let me use a different color pen so that you remember this. So the formula is Fn is equal to summation of I is equal to 0 n Li x fxi, where Lix, that is Lagrangian polynomial, is pi from j is equal to 0 to n x xj xi xj. But one thing that you need to know is that while you are writing down this polynomial, just make sure that I should not be equal to j. Okay. Basically, what is going to happen if I is equal to j? This will become 0 and it will become infinity, undefined. So that is why we don't use this. So this is the formula for Lagrange interpolation. Okay. And now let us see the formula for Newton's divided difference. Okay. So again, I'll write it down with a different color pen. Newton's divided difference. Okay. So the formula is Fn x, where n is the order of polynomial. Similarly, if you talk about here, n is order of polynomial. So I can just write down where n is order of polynomial. So this is fx0 x minus x0. So once we write down this equation, I'll show you the method how you can remember this equation, because this is a big equation, a bit nasty equation, which is difficult to remember, but I'll show you a trick how you can remember this. Okay, x0 x1. Now understand one thing, that this is not a typo. When I'm drawing a rectangular bracket here, this is not a typo. This is not something that I have done by mistake. This is something that I have done it purposely. Okay, this signifies that this is a divided difference. Now what is a divided difference? I'll show it to you later. But understanding that there should be this rectangular bracket, and when you talk about the first one, there is no rectangular bracket. This is just the round brackets. Plus this is going to be x minus x0 x minus x1 x0 x1 and x2. Okay, and if you continue this is going to be x minus x0 x minus x1 x minus xn minus 1 . So this is the equation for Newton's interpolating polynomial, or Newton's divided difference method. Okay. And the formula of divided difference is xi plus 1 is going to be fxi. So function of xi minus function of xi plus 1 divided by xi upon xi plus 1. Similarly, let us say we have xi. This is going to be xi plus 1, xi plus 2. This is going to be f function of xi. So divided difference of divided difference, basically. So plus 2, and we will continue this. So this is known as first finite divided difference. This is known as second finite divided difference. Let us talk about nth finite divided difference. So the formula is, please don't worry, this looks scary, but believe me, this is not at all scary. I'll show you the trick. I'll show you the technique, how you can remember the formula and how you can remember all these things. We'll follow a systematic procedure. So don't get disheartened because of the length of this formula. You don't even have to remember anything. It's just a tradition that I have to talk about this formula. Okay. If I wanted, I could have directly started with the problem, but I just wanted to show you how this formula is. Okay, so Lagrange interpolation and Newton's divided difference method. Okay, so in the next segment we are going to see a problem and see how we can apply this to solve a problem.